As a quick summary, we had a goal of a pH 3.00 buffer. We looked at some different acid options and we said, okay, if pH needs to be as close to pKa as possible, then maybe hydrofluoric acid would be good. But then we found out it's toxic and not that soluble. Nitrous acid, toxic and fairly soluble. And then formic acid, not that toxic and very soluble. So we ended up going with formic acid, even though the 3.74 was pretty far from 3. It's not a very good buffer system, and I'm sure we could have come up with a better one. Once we knew that target pH, we used the Henderson-Hasselbalch and said, oh, pH is pKa plus the log of A minus over HA. The catch was we knew the target pH. We knew the pKa, because that's just the negative log of Ka, and we had to solve for this. We couldn't solve for A minus or HA, we just could solve for the ratio, which gives us an infinite number of possible solutions. But we found out that our ratio of A minus to HA was going to be 0.182 to 1. And so we used that number to analyze a bunch of different amounts that gave us that same ratio and talked about what's too expensive, what's too much, and how do we come up with this generic idea of what to use. And so I made up a rule and I just said 10 times the increment amounts, which gave us, in this situation, I declared 0.05 moles of acid or base. And then substituting that into the equation, we got some pretty important numbers, and that was our 0.5 moles of the HCO2 minus and 2.75 moles of the HCO2H. All right, so this was our recipe based on this, which was based on the ratio, which was based on how we turn our formate buffer system into something that has a pH of 3. Then we looked at the examples for that, or the options for that, and we had 3 options, and those were option number 1, where we had our acid HCO2H plus NaHCO2. And we had some numbers there, and those numbers ended up being 34 grams of that and 458 milliliters of 6 molar that solution. And then you just mix them together. Amount doesn't even matter. As long as we have those moles, we have the right ratio. So that was the situation where we just combined the salt and its conjugate. We said there's another way that you can do that. We declared that was option number 2. And for option number 2, we were using a strong acid with our conjugate salt. So we said we've got HCO2 minus with HCl. And in this particular case, the amounts we ended up using were 221 grams of this. NaHCO2, and then for our HCl, 917 milliliters of 3 molar. And you can mix them to make any amount you want. We chose 1.5 liters in both of those examples, just arbitrarily. And then option number 3, let me scoot this up a bit. Was us taking our weak acid and mixing it with strong base. We have HCO2H plus OH minus from our NaOH. And in this case, we were using 3 molar sodium hydroxide, and we ended up needing 167 milliliters of 3 molar NaOH, and then 542 milliliters of 6 molar that. And again, you can mix those in any amount you want. So, real stumbling blocks in terms of coming up with a buffer system. First one, figuring out which system you're going to use. Second one, figuring out what your ratio is going to be so that you can pick whatever amounts you're going to need. And then the third way is based on what you have available, coming up with a way to make that buffer.